Welcome to Basic Foundation. Today's topic is trigonometry. Trigonometry deals with measurement of various parameters of a triangle. So let's get started. So let's say I have this right angled triangle, right angled at this vertex. So let's say I'm looking at this triangle from this direction. So this is our viewing angle. Let's call this angle theta. Now, with respect to this angle theta, this side is called the perpendicular and this side is called the base and this side is the hypotenuse. We also denote these sides by letter. We also denote perpendicular by P. So essentially P is this length, this as B and this as H. So with respect to this theta, this is the perpendicular P, this is the base B and this is the hypotenuse H. So let's first see how many different ratios are possible. So first ratio is P by H. Second ratio is B by H. Third ratio is P by B. We have three more ratios, H by P, H by B and B by P. So these are all the possible ratios which can be there for this right angle triangle. Now all these ratios have got special names. So this ratio is called sine theta. This ratio is called cos theta. This as tan theta. This as cosec theta. Sec theta, this as cot theta. A student is expected to memorize all these ratios and corresponding names. Another thing to keep in mind is that depending upon where theta is, this perpendicular and base will change. So let's say for the same triangle here, if we are looking from this direction, so this will be our angle theta. So in this case, the perpendicular will not be this, the perpendicular will be the side in front of the viewing angle, which is this. So this will be the perpendicular, this will be the base and this will be the hypotenuse with respect to this viewing angle. Next, we can see that sine theta and cosec theta are related. They are reciprocals of each other. So we can have three more formulas. So we have cosec theta equals 1 by sine theta, sec theta equals 1 by cos theta, cot theta equals 1 by tan theta. So cosec theta is reciprocal of sine theta, sec theta is reciprocal of cos theta and cot theta is reciprocal of tan theta. One more thing we can see that sine theta divided by cos theta will give us perpendicular upon hypotenuse divided by base upon hypotenuse, which upon simplification will give us P by B, which is tan theta. So we have two more formulas. Tan theta equals sine theta by cos theta. Similarly, cot theta equals cos theta by sine theta. So let's do a question to understand these trigonometric ratios. So let's see this question. In a given triangle ABC, AB is 5 centimeters, AC is 13 centimeter and this angle is 90 degree. So we need to find all the trigonometric ratios with respect to viewing angle A. Now we just saw sine of theta, where theta was the viewing angle. So in this case, instead of theta, we have A, which is this viewing angle, which is this viewing angle. So with respect to A being the viewing angle, this becomes the base, This becomes the perpendicular which we need to find, and this becomes the hypotenuse, which is 13. So let's first find out the perpendicular using the Pythagoras theorem. So b square plus p square equals h square. So this implies 5 square plus p square equals 13 square. So this will give us p as 12 centimeters. Now sine of angle A would be equals to perpendicular upon hypotenuse. That's 12 by 13. Similarly, cosec A equals h upon p, which equals 13 by 12. We could have also found out cosec A by taking reciprocal of sine of A, because sine A and cosec A are reciprocals of each other. Similarly, cos of A equals base upon hypotenuse, that's 5 by 13, and sec A equals hypotenuse upon base, that's 13 by 5. Tan of A equals perpendicular upon base, that's 12 by 5. Cot A equals base upon perpendicular, that's 5 by 12. Now this was the first part. Now in the second part, the viewing angle is C. So we are no longer viewing from this end, we are actually viewing from point C. So this is the viewing angle. So with respect to this viewing angle, this will become the base, which is 12. This will become the perpendicular, which is 5, and the hypotenuse will still remain as 13. Sine of C will be equals to perpendicular upon hypotenuse with respect to viewing angle C, that's 5 by 13. Tan C equals perpendicular upon base, that equals 5 by 12, and so on. Now next is measurement of angle. So there are two different units to measure angle. First is degree, which we all know. A small circle is used to represent degree. So we all know if two lines are perpendicular to each other, this is called 90 degree. If we have two lines which are horizontal, this angle is called 180 degree. Now we must also know that 1 degree equals 60 minutes. Just like we have 1 kilometer as 1000 meters and so on, smaller units, similarly degree can be broken down into smaller units which are called minutes, and 1 minute can be further broken down into seconds. So 1 minute is 60 seconds. Now radian is denoted by a superscript C, where pi radians, which is pi superscript C, equals 180 degrees. So we must remember that pi radians is 180 degrees. So let's do a few questions. So let's say we need to convert the given angles into radians. So first is 90 degree. So we need to convert 90 degree into radians. So we can just apply the unitary method, which is 180 degree equals pi radians. So 1 degree will be equals to pi by 180 radians. Then 90 degree will be equals to pi by 180 into 90, that's pi by 2 radians. Similarly, we can find 30 degree in terms of radians by using the same unitary method. So 1 degree equals pi by 180 radians. So 30 degree will be equals to pi by 180 multiplied by 30 that is pi by 6 radians. So few standard angles that we should remember is 30 degree equals pi by 6 radians, 45 degree equals pi by 4 radians, 60 degree equals pi by 3 radians, and 90 degree equals pi by 2 radians. These are few standard angles in radians that we must remember. Now let's do one last example. 22 degrees and 30 minutes. So we need to convert this into radians. So to convert, we must first write this into degrees. So if you recall, 60 minutes is 1 degree. So 30 minutes would be 0.5 degrees. So this can be written as 22.5 degrees. Now we can apply the unitary method. 1 degree equals pi by 180 radians. Therefore 22.5 degree equals pi by 180 multiplied by 22.5, which equals pi by 8 radians. Now next is convert the following angles into degrees. So first is pi by 18. So pi by 18 radians equals how many degrees? So we can again apply unitary method. Pi radians corresponds to 180 degrees. So 1 radian will be equals to 180 by pi degrees. So pi by 18 radians will be equals to 180 by pi multiplied by pi by 18. So that equals 180 divided by 18, so equals 10 degrees. So pi by 18 radians equal 10 degrees. Now if you notice, we could have also thought of it like pi is 180 degrees, so we could have directly substituted pi to be 180 degrees to get the answer. So this is a shortcut to convert radians into degrees. Another example is 5 pi by 12. So in this case, we will, instead of using unitary method, we'll just substitute pi as 180 degrees. So this equals 75 degrees, and so on. Now next is trigonometric ratios of standard angles. So these are 5 standard angles we must remember. We must also remember the value of these angles in radians. So this is 0 radians, this is pi by 6 radians, this is pi by 4 radians, this is pi by 3 radians, and this is pi by 2 radians. Now values of different trigonometric ratio of these standard angles. So sine 0 is 0, sine 30 degree is half, sine 45 is 1 by root 2, sine 60 degree is root 3 by 2, sine 90 degree is 1. So we have to memorize the values of sine of these standard angles. Now once you have memorized this, cos of these standard angles is just the reverse of these 5, which is 1, root 3 by 2, 1 by root 2, 1 by 2, and 0. So essentially sine theta increases from 0 to 1, where cos theta decreases from 1 to 0. So next is tan theta. So we already know this formula, that tan theta equals sine theta upon cos theta. So tan of 0 degree is sine 0 upon cos 0. So that 0 by 1 is 0. Similarly, tan of 30 degree is sine 30 degree divided by cos 30 degree. So this by this will give you 1 by root 3. Similarly, tan 45 degree will be 1, tan 60 degree is root 3, and 1 by 0 here we will get not defined. So tan 90 does not exist. So student must memorize this table. So let's do few questions on this. So find cosec pi by 3. So we know cosec pi by 3 is cosec 60 degree, which is 1 by sine 60 degree. Now sine 60 is root 3 by 2. So this will give us 2 by root 3. So cosec pi by 3 is 2 by root 3. Now second is cot square pi by 6. So cot square pi by 6 is cot of pi by 6 the whole square. Now pi by 6 is 30 degree. So cot of 30 degree whole square. Now cot theta is 1 by tan theta. So tan 30 degree is 1 by root 3 whole square. So finally we will get root 3 square equals 3. Third is sec square pi by 4 multiplied by cosec pi by 3 divided by tan pi by 4. So this equals sec square pi by 4 is sec pi by 4 the whole square. Now sec pi by 4 is reciprocal of cos pi by 4. So that's root 2 and the square. Cosec pi by 3 is reciprocal of sine pi by 3, which is 2 by root 3 divided by tan pi by 4 is 1. So finally we will get 2 multiplied by 2 by root 3 equals 4 by root 3. Now let's do a last one. Sine square 30 degree plus cos square 30 degree. So sine 30 degree is 1 by 2 the square. Cos 30 degree is root 3 by 2 the square. So this will give us 1 by 4 plus 3 by 4, which equals 1 plus 3 equals 4 by 4 equals 1, and so on. Now next, let's do this question. We are given cos of a minus b equals cos a cos b plus sin a sin b, and we need to find the value of cos 15. So we need to use this formula to find the value of cos 15 using the values of standard angles. So by observation we can see that cos 15 degrees is equals to cos. Now 15 degrees can be written as 45 degrees minus 30 degree, or we can write this as 60 degree minus 45 degree. Now we can apply the formula. So this will be equals to cos A cos B plus sin A sin B. Now by table, cos 45 degree is 1 by root 2. Cos 30 degree is root 3 by 2 plus sin 45 degree is 1 by root 2 and sin 30 degree is 1 by 2. So the answer is root 3 plus 1 divided by 2 root 2. This is the value of cos 15 degrees. Now let's move on. Next is trigonometric identities. In a given triangle, we know if this is theta, this is P, this is B, and this is H. So we can apply the Pythagoras theorem and get P square plus B square equals H square. Now let's divide both sides by H square. So if we do so, we will get P square divided by H square plus B square divided by H square is equals to H square divided by H square. Now P by H, which is perpendicular upon hypotenuse, we know it is sine theta. So this will become sine square theta plus this is base upon hypotenuse. So this will become cos square theta equals 1. So this is first trigonometric identity. Similarly, we can divide both sides by b square to get p square by b square plus b square by b square equals h square by b square. Now p by b is tan theta. So this will become square of tan theta, which is tan square theta. B square by b square is 1. H by b is sec theta. So this will become sec square theta. So this is another formula you must memorize. Similarly, the third part, we divide both sides by p square, and finally we will get 1 plus cot square theta equals cosec square theta. So these are three identities which we must memorize. So sin square theta plus cos square theta is 1. This is the most important identity that students must memorize. From this formula, sin square theta will be equals to 1 minus cos square theta. Similarly, cos square theta is 1 minus sin square theta. Among these three formulas, the first formula is very important. Now, since there are a lot of formulas, students are advised to prioritize what to memorize first. So going forward, the questions we will be solving, we will try and convert cosec theta, sec theta and cot theta in terms of sin theta and cos theta. So we will try and avoid these specific. So wherever we see cosec theta, sec theta or cot theta, we will convert them into sin and cos. And same thing, we will try and do it for the tan theta. So for example, let's try and prove the second identity using this formula. So we'll start with left hand side. So that's 1 plus, now this is tan square theta. Now tan theta is sin theta by cos theta. Now since there is a square, we will get sin square theta divided by cos square theta. Now we will take LCM. So LCM will be cos square theta. So just like we normally solve, here we will get cos square theta and we will get sin square theta. Now this we know it is 1, so this will be 1 by cos square theta, which is 1 by cos theta multiplied by 1 by cos theta, which is sec theta, and sec theta, which is sec square theta, equals RHS. Hence proved. Now let's do the third one. So we'll again start with LHS, which is 1 plus cot theta is cos theta upon sin theta, and since there is a square, this will become cos square theta divided by sin square theta. So again, if we take LCM, this will give us sin square theta plus cos square theta, that equals 1 by sin square theta. Now 1 by sin theta is cosec theta, so 1 by sin square theta will be cosec square theta, which is RHS, and hence proved. So we can prove most of the identities just by using this formula. If we make a rule of converting all these four terms, all these four trigonometric ratios into sine and cos. Now let's do a few questions. So first is cosec square theta plus sec square theta equals cosec square theta sec square theta. So we need to prove cosec square theta plus sec square theta is cosec square theta multiplied by sec square theta. So let's start with LHS. So cosec theta can be written as 1 by sin theta, and since there is a square, we will get similarly plus 1 by cos square theta. So now we can take LCM. LCM would be sin square theta cos square theta. This will come here, cos square theta plus sin square theta. So this will give us 1 divided by sin square theta cos square theta, because cos square theta plus sin square theta is 1. Now we can write this as 1 by sin square theta dot 1 by cos square theta. 1 by sin square theta is cosec square theta, and this is sec square theta. Now let's do another question. Now next is to prove tan A plus cot A equals cosec A multiplied by sec A. So A again represents an angle, just like theta. So LHS is sin A by cos A plus cos A by sin A. Now we can take LCM, that would be cos A sin A. Now sin A will get multiplied with sin A and we will get sin square A. Cos A will get multiplied with cos A, we will get cos square A, just like we normally take LCM. So the numerator will become 1, the denominator is cos A sin A. Now this can be written as 1 by sin A dot 1 by cos A, that's equal cosec A sec A, hence proved. Prove that tan square theta minus sin square theta equals tan square theta multiplied by sin square theta. So let's start with LHS. So LHS is sin square theta by cos square theta minus, this we can keep it as sin square theta. Now let's take LCM. Cos square theta, sin square theta minus sin square theta multiplied by cos square theta. Now if you see in the numerator, we can take sin square theta common. We will get 1 minus cos square theta divided by cos square theta. Now if you recall, 1 minus cos square theta is sin square theta. So this will be sin square theta divided by cos square theta multiplied by, this is sin square theta. Now this will become tan square theta multiplied by sin square theta equals RHS, and hence proved. So next is trigonometric ratios of complementary angles. So sin 90 minus theta equals cos theta. So if you notice, 90 minus theta and theta, these are complementary angles of each other. So let's see an example of the first formula. So sin 30 degree equals, we can write this as sin 90 minus 60 degrees, because this will again give us 30 degree. Now if you compare, sin of 90 minus theta equals cos of theta, which is cos 60 degree. Now we can also check that sin 30 degree is half and cos 60 degree is also half from the table, which is true. So let's see another example. Sin of 27 degrees equals, we can write this as sin 90 minus 63, because 90 minus 63 is 27. So this will give us cos 63 degrees. Now for competitions, this is a little lengthy method. A shortcut to this is, first you need to memorize that sin gets converted into cos and the angle is complementary to the previous one. So this is a two-step process. So the shortcut is, to convert sin 30 degrees, we first convert sin and then we take the complementary of 30 degree. So sin will get converted into cos, sin gets converted into cos, and the complementary angle of 30 degree is 60 degree. So sin 30 degree equals cos 60 degree. Similarly, sin gets converted into cos and complementary angle of 27 degree is 63 degrees. This is how we use this formula. Now just like sin gets converted into cos, cos also gets converted into sin the same way. So if someone asks, how can you convert cos 15 degrees into sin? So we can write this as, cos will get converted into sin and 15 degree, its complementary angle is 75 degrees, and so on. So same rules can be applied for this as well as this formula. Now since we have already seen that we try and convert everything into sin and cos, so it is enough that if we memorize this formula. So let's do one more. Tan 6 degrees is equals to, so tan will get converted into cot, and 6 degrees, its complementary is 84 degrees. So tan 6 degrees is cot 84 degrees, and so on. Now let's do questions on these formulas. So this is the first question. So we know sine 90 minus theta is cos theta. So we can write this as sine theta cos theta, and this will become cos theta. Cos of 90 minus theta is sine theta, plus, now this is cos theta into sine theta. Cos 90 minus theta is sine theta divided by sine 90 minus theta is cos theta. So sine theta and sine theta will get cancelled. Similarly, cos theta and cos theta will get cancelled, and we will get cos theta into cos theta, which is cos square theta, plus sine square theta, which we know is 1. So this equals 1. Let's do another one. Sine square 20 degrees plus sine square 70 degrees. Now to simplify this, first thing we should notice that 20 degrees and 70 degrees, these are complement of each other. So we must try and convert one angle into another. So let's keep sine square 20 as it is and convert sine square 70 into 20 degrees. So sine square 20 plus, now this we can write as cos square, and complementary of 70 degrees is 20 degrees. Now this is a formula. Sine square theta plus cos square theta is 1. So this equals 1. Let's do another problem. Sine square 17 plus cos square 41 plus sine square 73 plus cos square 49 degrees. So first we have to look for the pairs whose angles are complementary. So if you notice, 17 degrees and 73 degrees, these are complementary of each other. So we'll write sine square 17 degrees as it is, and we will convert sine 73 degrees into cos square. Complementary of this is 17 degrees. Now similarly, we'll just keep this as cos square 41 degrees, and if you notice, 41 degrees and 49 degrees are complementary. So we'll convert this into sine square 41 degrees. Now we can see that sine square 17 degrees plus cos square 17 degrees equals 1, plus cos square 41 degrees plus sine square 41 degrees equals 1. So the answer is 2. Now next is tan 5 degrees multiplied by tan 85 degrees. Now again, 5 degrees and 85 degrees are complementary of each other. So we'll try and convert one into another. So this will keep it as it is. Tan 85 degrees will become cot 5 degrees. Now we know that cot theta is reciprocal of tan theta. So cot 5 degrees is 1 by tan 5 degrees. So this will get cancelled with this, and the answer will be 1. The next is tan 10 degrees multiplied by tan 20 degrees multiplied by tan 30 degrees, and so on to tan 70 degrees multiplied by tan 80 degrees. So let's say we need to simplify this. So just like we did this, we will try and make pairs of the terms which have complementary angles. So if you notice, tan 10 degrees multiplied by tan 80 degrees will be equals to tan 10 degrees. Now this will get converted into cot 10 degrees. Just like we did previously, this will become 1. Similarly, tan 20 degree will be paired with tan 70 degrees. Now that will be equals to tan 20 degree cot 20 degree, and that will be equals to 1, and so on. So if we start making pairs, in total we will get 4 pairs, and all of them will be 1. So the answer will be 1 multiplied by 1 multiplied by 1 multiplied by 1. So that will give you 1. Now let's do this type of question. So the question is, A tree breaks due to storm. So let's say we have a tree which breaks down due to storm. So let's say it breaks down from here, and the top of the tree touches the ground like this, making an angle 30 degree with it. So essentially this angle is 30 degree. Now the distance between the foot of the tree, which is this, to the point where the tree touches the ground, which is this, is given as 10 meters. So they're asking us to find the height of the tree. So essentially this plus this length. So let's see a proper diagram. So let's say this was the tree, and this is how it was. It broke down from here. Now the angle it makes is 30 degree. This length is given as 10 meters. We need to find the height of the tree. So let's call this height as x and this as y. So if this is the case, we can see that the height of the tree will be x plus y. So essentially we need to find x and we need to find y. So we use trigonometric ratios. If you realize this is a standard angle, so we know all the values of trigonometric ratios of this angle. So let's say we try tan 30 degree. So tan 30 degree will be perpendicular upon base, so equals x by 10. Now we know tan 30 degree is 1 by root 3 equals x by 10. So this implies x equals 10 by root 3 meters. So now we have this length. Hence we can also find y either using Pythagoras theorem or using another trigonometric ratio. Cos 30 degree equals base upon hypotenuse, so 10 by y. So this implies root 3 by 2 is equals to 10 by y. So this implies y equals 20 by root 3 meters. Therefore height of the tree equals x plus y, which is 10 by root 3 plus 20 by root 3 equals LCM is root 3, and we'll get 10 plus 20, which is 30. Now we can rationalize this, root 3 by root 3, so we will finally get 10 root 3 meters. So the actual height of the tree is 10 root 3 meters. Thank you. Students are advised to practice sums